Hi everybody, here we have a linked list which is being implemented on an array. It's a linked list of nodes. Each node has a data item and a pointer to the next index in the list. So our root pointer shows us that it has a value of 0, so this is the start of the linked list. So we start at 0, the next pointer takes us to index 1, the next pointer takes us to index 4, the next pointer takes us to index 2, the next pointer takes us to index 7, the next pointer takes us to index 3, and that's the end of the list. Also, from the previous tutorial that we looked at, unused elements within the array that we're using to implement our linked list can form a free list. So this is kind of a free list of nodes that are available for us to maybe use. So what we've just done there is we've inserted a node into our linked list, and the new free list moves here. This is the new free list, and this is our linked list with the new node inserted. Now you can see that from 3 we're now jumping to 5. So this next pointer has to be updated to 5. We also saw that the free pointer was 5, but finally it became 6 because we moved it to the next index, the next pointer from the original free start of the free list. So this becomes 6. If we were to add another item, the new item would go here, and the next start of the free list would be at index 8, etc. Okay? If the free pointer goes to 9, by the way, and we insert a node at 9, the free pointer is going to have a new value of -1. And there's a nice little bit of logic we can do there to check if we can insert a node into a linked list. If the free pointer has a value of something like -1, it means the list is full and we can't insert. So that's a useful bit of logic to remember. So at the moment, our free pointer is at index 5, and our new node has been constructed, but it hasn't been inserted yet into the list. We'll do that in a moment. We also need to remember that when we insert the new node, we overwrite a really important piece of data. We overwrite this value. This value is going to tell the free pointer where it should jump to. So we don't want to overwrite that. We want to store it before we put the new node into place, because we'll need it later. Okay, so let's think about some of these concepts, and let's start to code an insertion of a new node at the end of a linked list. So here we've got a definition of our node class. Every node object has 2 attributes, a data item and a pointer to the next node in the list. We also set up 10 nodes, and we've just copied this design. So node 0 has these 2 values, 13 and 1. Node 1 has these 2 values, 15 and 4. Node 2 has these 2 values, 21 and 7. There it is, node 2, 21 and 7, etc., etc. Then we push all those nodes into a linked list implemented on an array. And today we're just going to design a new node. There it is. It's not in the list yet, it's just a new node, and it exists independently. Now let's get started with some programming. The root of our linked list is 0. There it is, that's the root pointer. I'm also going to log where the free pointer is. I'm also going to store that very important value, because that's going to be the new value of the free pointer later. After we've done lots of processing, we're going to move this to here. So we really need to record that value before we do this, which will overwrite it. Okay, so I'm just going to say new free pointer is equal to the current value of free pointer, which is 5. Now then, let's put this node into place. Linked list at index free pointer will be assigned the new node. Done. This is what's just happened. Bing. Now notice, with my new node, I have given it a next pointer of -1 because we're inserting it into the end of the list. So it's logical that I would give that the new ending signifier, which is -1. Now that does mean that this node here is no longer the end of the list. 3 will jump now to 5. 3 will jump to the current value of free pointer. So this should be the value that is stored by free pointer. So we need to find a way to get this value of 3, because this node, linked list 3.next, will be equal to free pointer, which is 5. So that will update to 5. So we need to find a way to grab this value. So let's look at how to do that. I'm just going to create a new pointer called loop pointer. I'm going to assign it a value of root, which is 0. We'll use similar logic to what we did in the previous video. We're just going to loop through the linked list until the loop pointer is equal to -1. So while it doesn't equal -1, we're just going to update the loop pointer. And hopefully this line of code now makes sense to you. Okay, so loop pointer starts at 0. Loop pointer equals linked list 0.next, so loop pointer becomes 1. Loop pointer equals linked list loop pointer dot next, so loop pointer becomes 4. Then it becomes 2. Then it becomes 7. Then it becomes 3, and then it becomes -1. Okay, so let's print the value of loop pointer after this while loop has finished processing. Free pointer is not defined. Free pointer was 5. Free pointer. Okay, let's run that. Whoops, I forgot to put it in curly brackets. Now there's an interesting basic error. Let's run it again. So we've reached the end of the list, we know that. What we haven't managed to grab is that index. This is the next pointer, and this is the current node. We need that value. So let's look at a bit of logic to do that. Current node index is equal to loop pointer. So let's grab the loop pointer before we update it. Okay, so let's look at how that works. Loop pointer starts at 0, current node index becomes 0, and loop pointer updates to 1. And then current node index becomes 1, and loop pointer becomes 4. Current node index becomes 4, loop index becomes 2. Current node index becomes 2, loop pointer becomes 7. Current index becomes 7, loop pointer becomes 3. Current node index becomes 3, and finally loop pointer becomes -1. So hopefully we've grabbed the index of the current node that we're at, because we need that value. Let's just check. Let's run that. Yes, we grabbed it. We've got it. So we know where we are in the linked list. We know the index of the node that's currently the final node in the list. So that bit of logic there worked. Think about it and see if you can figure out how that's working. So now that we have this index, we can do this. Linked list at this node, which is current node index, dot next. So this value here will become the value of the free pointer. Okay? So we've fixed this node onto the list. It's the new end of the list. This has become 5. This is -1. This is the new end of the list. Free pointer, of course, has to move over here. And we stored that value already up here. Do you remember that? Oh, new free... oh, I've got it wrong, haven't I? New free pointer equals linked list free pointer dot next, because we wanted to grab no, that's not true, is it? Oh yes, it is true, because that was the original dot next, so that was the 6 that we were trying to store. That line of code will store it for us, and now we can say free pointer equals new free pointer. So we're updating free pointer. Okay? So this is the current situation. We've just updated free pointer to be the value of 6 that I stored before, which I call new free pointer. Done! This is our new free list, and this is our updated linked list, with this being a value of 5 now. Now, just to see that everything's working, let's just reset loop pointer to be 0, because I want to loop through the linked list again. Let's call it root, because root never changed. Root is still 0. While loop pointer doesn't equal -1, we're going to print the value at that index, and we're going to update loop pointer. Okay, so hopefully this logic here is becoming very familiar to you. Just want to print out each data item, 13, 15, 17, 21, 23, 29, and hopefully 13 is now a member of the list. Let's run it and find out. Oh, free pointer, I've done it again. Free pointer was new free pointer. Oh dear, there it is. Let's run that again. So let's have a quick look. 13, yep, 13, then 15, 17, 21, 23, 17, 21, 23, 29, 13. That is how to insert a new node at the end of a linked list.